I was not originally involved in marine debris research, but this is something that I've gotten involved with in the last 3 months. So I'm really new at this, but it's really exciting to me. These are basically waste products, plastics, those sorts of things. And they're derived from a number of different resources, from terrestrial garbage that ends up blowing out to sea or is transported, commercial and recreational boats, either again with waste kind of flying off of these boats or nets being lost, and containers being lost from cargo ships, and that's kind of my part-time job. I'm a Coast Guard Marine inspector working on some of these ships. And this is a pretty common occurrence, actually, unfortunately. What are marine debris composed of? Most of the time, these are going to be larger plastic products that are breaking down in the ocean through sunlight, through wave action and bacterial processes. So these are larger components. They're broken down into smaller pieces, and they're winding up inside of wildlife. There are also these nurdles, and I don't know if you're familiar with that word, but they're basically these proprietary particles that are used, melted down, and then formed into plastic components, okay? So this is what turns into a plastic bottle, not necessarily what happens afterwards. In the shipping route that goes through the Aleutian Islands, apparently containers and containers of these things fall off of boats, and they just are getting spread throughout the ocean up there. And then, like I said, nets and other linear objects. And when I say linear objects, one of my colleagues from Clemson University actually looked at what happens when sea turtles are eating balloons that fall into the ocean. And the balloons weren't actually the problem. The balloons passed fairly readily through the turtles. But what happened was that nylon string attached to the balloon got caught up inside of their intestines, basically, and caused those turtles to die that way. These linear objects, coffee stirrers and straws, don't use them. Leave it alone if it's a plastic coffee stirrer, okay? That's just my little soapbox for today. But plastics, especially these marine debris plastics that are in the oceans, these essentially represent poison pills. The plastics themselves can be toxic because of what they're made out of, what they've been mixed with, okay? So they'll have phthalates, BPAs, PBDEs, TBPAs, and a handful of other chemicals that they can be mixed with. They also absorb or adsorb other contaminants onto their surfaces. So here we've got not only some of the things that they can be comprised of, but they also, in a lot of cases, will be kind of attractive to things like lead, methyl mercury, copper, things like that. So when an animal eats a piece of plastic, it's not just getting the poisons within the plastic, it's getting all those things that are sticking to its surface, like heavy metals. Some of the primary things that you're going to see when wildlife consume plastics is internal damage. Blockages are another major issue, so these things often cause starvation and secondary infection. Some of the chemicals that are associated with these plastics, like the phthalates, are endocrine disruptors. So they have negative impacts on an animal's hormones. So that could mean that something is not going to be producing gonads and eggs and sperm and things like they're supposed to. They may have behavioral changes that they undergo because of changes in their hormone levels. They may not go through the proper mating behaviors that they normally would, and in some cases, male animals appear to look like females. It's called feminization. Those are issues that can happen. The liver is the organ that essentially filters things that are going through the bloodstream. If you have contaminants in an animal, its liver is going to be one of the first things that gets damaged. So you can have liver failure, as well as damage to the nervous system. And this is especially a lot of those organic chemicals where you'll have animals that can't properly preen or clean themselves. They can't forage like they should be foraging. In a lot of cases, they aren't able to dive or hold their breath either. And recent studies have shown that seabird populations worldwide are declining, and that's consistent for nearly every single species of seabird. So that brings me to marine debris and birds specifically. I am a bird parasitologist. The most common cases that we see in birds are entanglement. Monofilament line is a huge issue with wildlife. Some of that we can prevent by having people actually properly dispose of monofilament, but lines break while people are fishing, and in a lot of cases birds get entangled in fishing line. Feeding is the other major way, right? So things like albatross are they're attracted to shiny, plastic, colorful objects. So they preferentially feed on plastics when they're in the water. And in this case, they cause blockages and they can't fit any more food in their stomach and nothing can pass through, so they starve. Other birds are going to forage on plastics kind of more accidentally. They think it's a food item, like a traditional prey item. Birds that eat things like copepods and other plankton, the most energy-rich copepod is going to be one with a whole cluster of eggs stuck on it. And that's what a nurdle looks like when it's floating in the water. So in a lot of cases, these birds are mistaking plastic pieces for their food items. But indirect feeding is also an issue. And this is more common when you have birds that are more apex predators. So these are the ones that are eating fish, they're eating crabs, they're eating animals that eat other animals for a living. In this way, they're not necessarily going for a piece of plastic, but instead they're eating a fish that has eaten plastic. And in that way, it's a bigger problem because they're being exposed to more and more plastics than they would even if they were eating them directly. And so a recent study in the last 6 months came out basically showing that nearly all seabird species are now consuming plastics. So not only are they all declining, but they all happen to be eating plastics. And what they actually were able to find is that through looking in the guts of seabirds, 80% of the species recorded are eating plastics now. And unfortunately, most of the damage is already done. This stuff is in the ocean, and this is great, that y'all are coming together for this to try and prevent more waste from getting into the oceans and generating less waste in the first place. But this is happening already. Our seabirds are in really big trouble already. But the new research that I'm doing is directly related to plastics. We started this in November, and the research project is called Parasites, Plastics, and Poisons in Seabirds. And this is kind of looking at everything, how they're interacting with the food web, that they're eating plastics, and how they're getting contaminants from the plastics themselves. We're focusing on 10 species of birds from western Aleutian Islands. So this is Alaska, unfortunately, not California. And the species are really different. These birds are actually a indicator in Europe for plastic pollution. Some people are using them to basically monitor the status of plastics in the ocean. But basically 70% of the 20 birds we went through had plastics in them. But again, this is kind of ongoing or preliminary research that we're doing, so we're still seeking additional funding to try and get students and more people involved with this research. We've got about 10 undergraduates at UCSD involved in it already, but we're looking to help fund to get more undergraduates involved in the research.